All right, we move to the next section, which is section 3. Section 3 is applications of dimension. Now, what are the applications of dimension? What is uses of dimension? Now, if you can recall, dimension is just the art of representing quantity. Dimension is the relationship between quantities. Now, what is the uses? What are the applications of dimensional analysis? Now, the applications of dimension is that, please take note of this. Dimension is used to show whether an equation is correct or not, okay? It's used to show whether an equation is correct physically or dimensionally, okay? It's used to show whether an equation that has been derived is correct or not. Now, how do you know if an equation is correct? Now, an equation is dimensionally correct when the right-hand side of the equation. Remember, the right hand side of the equation is the part after the equal to sign. Okay, so an equation is said to be correct when the right hand side of the equation is equal dimensionally to the left hand side of the equation. So when these two parts are equal dimensionally, when I mean dimensionally, when the total dimension here is the same or is equal to the dimension here, you will then know that the equation is correct or not. But if these two parts are not the same dimensionally, you will know that the equation is not correct. Now, how do you carry out dimensional analysis? We need to first look for the dimensions at this side and also look at the dimension at this side. If we compare the two and find out that the two dimensions are equal, you know that the equation is correct. Now, before I continue, you guys know that the dimension for length is capital letter L. Yes, you guys know that the dimension for length is capital letter L, while the SI unit used to measure length is what? Is meter. The dimension for length is capital letter L, while the SI unit used to measure length is meter. Now, before I continue, you find out that if you look at the board very well, you find out that I place other quantities in the board, which are displacement, distance, height, altitude, breadth, and width. Now, all these quantities, all these quantities, they all come from length. They are all related to length. So since they are in the same family with length, they will also have the same dimension and the same SI unit with length. The dimension for length is capital letter L. Then all these other quantity like displacement, distance, height, altitude, breadth, width, since they are related to length and since they come from the same family as length, they therefore have the same dimension as length. That's to tell you that the dimension for displacement, distance, height, altitude, breadth, and width is what? Is capital letter L. While their SI unit is what? Is meter. So all these quantities, they all have the same dimension with length and as well as the same unit. This is because they are related to length. They originate from length. Now, let's go back to dimensional analysis. Now, we before I start comparing the two parts of the equation, let me just teach you guys a little thing. Let's go back to mass indices. Okay. Now, according to a particular law in indices said that a particular law in indices said that if a over b is the same thing as ab raised to power minus 1. A over b is the same thing as ab raised to power minus 1. B raised to power minus 1 means that, okay, b raised to power minus 1 is the same thing as, this minus here means 1 over, okay, this minus here means 1 over, then you place the b, then you put the 1 here, 1 over b1. So b1 is the same thing as b. So this is to tell you that b raised by minus 1 is the same thing as what? 1 over b. If you multiply 1 over b with a times 1 over b, you have what? A over B. You have it back. So this to tell you that A over B is the same thing as what? AB raised to power minus 1. As B raised to power minus 1 is the same thing as 1 over B1, okay? Yes. The B1 is still the same thing as B raised to power 1 means B times just B. So B raised to power 1 is the same thing as what? 1 over B. B raised to power 1 means B, okay? So now let's continue. Same this is, for example, A over B square is the same thing as AB raised to power minus 2. Okay? Same thing as AB raised to power minus 2. Now, B raised to power minus 2. B raised to power minus 2. I told you guys say like that. I told you guys that this minus is the same thing as 1, it means 1 over. Okay? This minus means 1 over. Then bring out the B. Then place the 2 there, okay? Yes. Now, if you multiply this with A, you will have what? A over B, A over B square. So, yes, okay? A over B square. Now, this is just one law in indices. Now, another law in indices also state that, for example, let's say, for example, A2 then times A3. Now, a particular law in indices tells you that when two base are equal, say that when two base are equal, like for example a squared times a cube. Now when two base are equal, you take one of the base and then you add what? You will add their power. This is one law in indices. When two bases are equal, you take one of them based on the fact that they are equal, then you will add the power together. So since a squared times a cube, since these two bases are the same, you take one of the base which is a, then you add their power to be 2 plus 3. This will be what? A5. Okay? Yes. So this is another law in indices that tell you that when two bases are equal, you just take one of the base and then you add their power. What about, for example, a minus 3 times a 2? Since these two base times a raised to power 2, since these two base are equal, you just need to bring out one of the base, then you add what? You add their power. Minus 3 plus, this times return to plus, minus 3 plus 2. We have what? A raised to power minus 1. Okay? Yes, minus 3 plus 2, that is minus 1. Okay? So, okay, so this is another law in indices. Then also be another law say that, for example, a over a. Okay, let's say this one is 2 and this one is 3. Now a square all over a cube. Now it's still the same thing as the previous one. You just need, based on the fact that the two base are the same, you take one of them and you what? Subtract the power. Okay? That is when two bases are dividing each other and the two bases are the same, you take one of the base, then you what? Subtract their power. But when two bases are multiplying each other, you take one of the base, you will add their power, okay? But when two bases are dividing each other, you take one of the base, you subtract the power, okay? So in this scenario, you take one of the base, then you what? Subtract the power. So 2 minus 3 will give you what? Give you minus 1, okay? Yes. But when two bases are multiplying each other, when the two bases are multiplying each other and these two bases they are equal, you bring out one of the base, then what? Power, you add their power, okay? Yes, please and please don't forget about these laws, because we usually use them to look for dimensions of some quantity and also do dimensional analysis. So So in summary to what I just said, I told you guys that when two bases are multiplying each other and those two bases are equal, you take one of the base, then you add the power. Then also when two bases are dividing each other, and if these two bases they are equal, you bring out one of the base, you subtract the power. Now let's move back to dimensional analysis. Now how do you know if are these equations are correct? Now before then, if you check out this second equation is the same thing as S equals to UT plus half AT square. Okay, then even this other one is the same thing as V square equals to U square plus 2AS. Now now in your textbook you find out that this x is replaced by what? Ox. It's the same thing. This ox stand for distance or displacement. The ox stand for distance and displacement. The s also stand for what? Distance and displacement. So you can use them in place of each other. Ox can be used in place of s. Okay, so they are also they are the same thing. Okay, now, how do you carry out dimensional analysis? How do you know if an equation is correct or not? An equation is said to be correct when when the right hand side of the equation is when the right hand side of the equation has the same dimension with the what? With the left hand side of the equation. Now, to carry out this dimensional analysis, we need to look for the total dimension here, and we need to look for a total dimension here as well. Now, how do you look for dimensions of some quantity? Now, the important thing you need to know in order to look the dimension of particular quantity is that know the formula of that quantity. If you know the formula of that quantity, you can easily get the dimension of that quantity. Okay, so just know the formula of the quantity. Now, before I continue, take note that values values are symbols. Values, when I mean values, like one, two, three, four, five, half, any value at all. Values they don't have dimension. Okay? Values, when dealing with dimensional analysis, values don't have dimension. Okay? Also, symbol like pi. Pi does not have a dimension. Please take note of that. Values like one, 2, 3, 4, 5, 6, any value at all, when they are placed in an equation, if you look at this equation and you see half here, now whenever we're looking for the dimension of this quantity of this equation, just know that we will neglect the value there because why value don't have dimension. If you also see here, you see 2 is us. This 2 is a value. 2 does not have a dimension. Also, symbol like pi does not have what? Does not have dimension. Now let's just in summary to what I told you guys earlier under indices was that A B okay A over B is something as what? AB raised power minus 1. I told you guys why is AB raised power minus 1. I also told you guys that when the same base are multiplying each other, we will take one of the base, then we will add what? We add their power together, okay? Yes. Then the last one I told you guys, I said that when two bases are dividing each other, when two equal bases are dividing each other, you will you take out one of the base and you what? You subtract the power, okay? You subtract the power. So please don't forget about this. Now, let's go back to dimensional analysis. So I also tell you guys that values they don't have dimension, and also symbols like pi and other symbols, they don't have dimension. Now, okay, let's start with this very first equation. Is this equation correct? Let's find that. Now let's look for a dimension here and also let's look for a dimension here. Now I told you guys that if you want to look for a dimension of a quantity, you need to know the formula of that quantity. Now velocity, where is the formula of velocity? Velocity is what? Displacement. Velocity is displacement over time. Okay, this is the formula for velocity. Velocity is displacement over time. And what is the dimension for displacement? Now I told you guys earlier that Quantities like displacement, distance, height, altitude, breadth, width, they have the same dimension as length. They have the same dimension as what? Length. This is because they are from length family, they are related to length. And what is the dimension for length? Dimension for length is capital letter L. So displacement, the dimension of displacement will be what? Will be capital letter L, because displacement and length, they are from the same family. Then over, over, what is dimension for time? The dimension for time is what? Capital letter T. So this will tell you that L over T is the dimension for velocity. Now, according to indices that I told you guys earlier, I said A over B is the same thing as what? AB raised power minus 1. Abi? Now, if you compare it with this, L over T is the same thing as what? LT raised power minus 1. Okay? So the total dimension at the left hand side of the equation is what? LT raised power minus 1. Okay? Now let's look for the total dimension here. If the total dimension in the right hand side of the equation is the same with the dimension at the left hand side of the equation, you know that this equation is correct. Okay? Now let's move to the right hand side of the equation. This is also the u is velocity as well. So what is the dimension for velocity? We find out that the dimension for velocity is what? Is LT raised power minus 1, then plus. Now what about acceleration? Well, acceleration, I told you guys that now if you want to look for the dimension of a quantity, you will need to know the formula of that quantity first before you start to look for a dimension. Now, what is the formula for acceleration? Acceleration is velocity over time. Okay, yes, acceleration is velocity over time. Now, what is the dimension of velocity? Dimension of velocity is what? LT raised power minus 1, then over. What about time? What is the dimension for time? Dimension for time is what? Is t. Now, let's go back. Okay, I'm coming. Okay, so is equals to dimension for velocity is what? LT raised power minus 1, then over. Dimension for time is what? Is capital letter T. Okay, yes. Now, if let's go back to indices. I told you guys that whenever the same base are dividing each other, whenever the same base are dividing each other, for example, okay, whenever the same base are dividing each other, you take out one of the base, then you subtract their power. You take out one of the base, then you subtract the power. 2 minus 3 will now be what? A raised power what? Minus 1, okay? Yes. Now let's go back to here. If you look at here very well, you find out that two equal bases, they are dividing each other, which is what? T raised power minus 1 over T. These two bases, they are what? They are equal. So since these two bases are equal, we bring out one of the base, then we subtract their power. Okay, so minus 1, then uh,